Hi, today we are going to talk about our OSS project, which is to evaluate replacing C image and font libraries with modern Rust equivalents. I will now provide a walkthrough of our project as we implemented it. Servo is an experimental web browser layout engine being developed by Mozilla Research for new generation hardware. The project has a symbiotic relationship with the Rust programming language in which it is being developed. Rust is a new programming language for developing reliable and efficient systems. Servo currently depends on a lot of C libraries because Rust equivalents did not exist when the project started. We want to evaluate switching some of these to new Rust libraries that have been created. This project involves rewriting the code that uses these libraries as well as taking measurements before and after to determine the costs involved. To accomplish this, we have to follow a number of steps. For our OSS project, we were assigned to complete 1. Build Servo, 2nd. Add timing code to the image decoding implementation, then rebuild the servo and print the timing code for different types of images. During the course of our project, we worked on Ubuntu Linux machine. We first installed the Rust compiler and some prerequisites like GLFW packages, etc. To build the servo, we cloned the repository using git clone https github.com servo/servo. So this is the command that we wrote on the terminal as shown. We built the servo using the macbuild command. As you can see, the servo is now building. Now our build has been completed. We run a test URL using the following command. This is to check whether the build was successful. Since the Mozilla servo page has opened, we now know that the build was successful. We now try running a new URL, such as google.com. So now our tests are running and the build was successful. Once the server was built, we started the next step, that was adding timing code to decoding implementation. In the image underscore cache underscore task rs file, which is a Rust file, we had a fn decode function which calls the load from memory function in the base.rs file. Image decoding is implemented in this load from memory function. So we added the timing code around this function call in the image underscore cache underscore task rs file. The precise underscore time underscore ns function gives us the current time. So we added this before the call to get the start time of the decoding and after the call to get the end time of decoding. The difference of these two values give us the decoding time, which was then printed on command line using the println function. We now take a PNG file which has a resolution of 512 into 512 and we run the command as follows, which is the macrun command, and we will get the decoding time for that image. As you can see, the time required for decoding has been printed on the command line. We have taken different sizes and formats of the Lena images and recorded the time in milliseconds for these different formats and resolutions, as you can see on the screen. Having completed all this, we have thus successfully implemented the requirements specified in our OSS project. Thank you.